Okay, so for the first question, or I guess not really a question, but like something to talk about, is the critical path. So, they say if we had a circuit like an array multiplier or something, and you tried all the possible inputs and found the one with the worst propagation delay, we would call that path the critical path. This is important because it determines the max speed we can run the clock at for the circuit. And since if we were to run it faster than the critical path speed, the circuit wouldn't have time to get to the right answer before the next clock edge, which is a good thing. Obviously, you want the right answer. So it makes sense to believe that the most significant bit would be the slowest output since usually takes the longest depending on the number, but this isn't always true due to the like different logics and carries, for example, in the array multiplier. Okay, so for the next question, 2A, it asks us to find VM mathematically. So A here, VM can be described as VO max minus VO min divided by 2, which in this case is 6 minus 0 over 2, so that equals 3 volts. Okay, so for the next part, it says find the gain mathematically. So we know the gain is equal to G equals to 2 times K prime times W over L Vm minus Vt times 1 over 2 times lambda times IDS. And we have everything here except for IDS. So we're going to have to solve for IDS in this case. So IDS in this case would be K prime over 2 times VGS minus VT squared times 1 plus lambda VDS. And now we can just plug in the numbers we were already given. 2 times 10 negative 6 over 2 times 3 minus 0.5 squared times 1 plus 0.07 times 3. And in this case, we found VDS to be, which is equal to VDD minus VO, but this is also equal to VDD minus Vmin since that's where we're operating at. And in that, and this is also why we're using the saturation equation, because at that point, the MOSFET and both MOSFETs are in saturation. So once we calculate that number, we get 756 microamps. And now that we have the current, we can just solve for the gain now. So 2 times prime, which is 200 times 10 to the negative 6, and d minus 0.5 times 1 over 2 times 0.07 times 756 times 10 to the negative 6. And here G is equal to about 9.45. And then, okay, so now we're on the next part and it asks to find VIL. So VIL is pretty simple to find. We're just going to use this equation that we were given. So VO max is equal to negative G times VIL plus VM 1 plus G. So we already have all these values, including the G we just found from before. So we're just going to go ahead and plug in the numbers. So 6 equal to negative 9.45 times VIL plus 3, 1 plus 9.45. And then if we just calculate that and solve for VIL, VIL turns out to be 2.68 volts. And likewise, the next part is finding VIH. And we're going to pretty much be using the same equation except substituting VI max for VO min and VIL for VIH. So let's go ahead and do that. And then VIH turns out to be around 3.32 volts. Okay, so then for the last part, it wants us to do 3A. And this one is asking us to find, well, it tells us first that the VTs of the PMOS and the NMOS are equal for an inverter. And then it asks us, so what's the width for the PMOS? Would you need to make the time propagation from high to low and the time propagation from low to high times equal for an inverter? So in order to start this problem, we first assume that there's some capacitance at the output, and at uh, at the output V out, such that there's Q equals CV, right? So let's just write that down. And we can take the derivative of this, and just get I equals C dV dt. And since time propagation measures the time it takes for our voltage to change, we can set the current at the PMOS and the NMOS equal each other so that our dB dt is equal, and hence the time propagation, since dB dt is the change in voltage. We use the MOSFET saturation equation here because we assume our Vin changes instantaneously, meaning VDS for both our PMOS and NMOS is in the saturation range. So let's just write that down. What I just said, IDS of N is equal to IDS of P. And we know those equations for saturation range is Kn prime over 2 times Wn over Ln times VDS minus VT squared equal to K prime over 2, and pretty much the same thing, but in terms of the PMOS. And then here we put the absolute value because it's negative in this case, but we just want it to be the same magnitude. And since VT of N and VT of P are equal to each other in this case, we can just cancel these out since they're the same quantity. And then eventually we're just left with this. Or we can also cancel out the t's because they're both on both sides. And then we can just go ahead and rearrange this as well. So Kn over Kp prime over W, W over L sub P and W over L sub N. And at this point, we just get the numbers from the schematic, which turns out to be 560 over 380 equal to WP over 10 times 10 to the negative 6. And WP in this case turns out to be 14.47. And once we put that into the schematic, we can see that the times shift closer to more closer to each other. Obviously not exactly the same because there's other factors, but pretty close.